Greetings to you, my electronic entrepreneurs. Today we're going to wire a simple controller together. So to begin with, let's take a look at the parts that we're going to need. So of course we're going to need an Arduino board. We will need a USB cable to connect it to our computer, a couple of switches, a potentiometer. We'll need a whole slew of wiring, different shapes, sizes, colors. We are going to need some LED lights to be able to use, some resistors, and of course a breadboard. Through the magic of physical computing, we're going to take all these discrete parts and make them work together. So let's take a look at the actual Arduino board. We'll be using Arduino Uno. Down here in the bottom is the power section. We'll be using the 5-volt section as well as one of these ground ports right here. The chip is in the middle right there. The analog components will plug in through the analog, and our digital components will plug into those digital ports up at the top. There's a USB port on the side there that you'll use to connect the board to your computer. The power rails of the breadboard run the full length of the board. There's a place for a power and a ground. Then, on the inside, the power rails go east-west, or the width of the board, and they stop at that center segment, and they start again on the other side. And likewise, there's a power rail and a grounding rail on the top as well. To start, let's hook up a power and a grounding wire into the Arduino. I use a black wire for power. I'm going to put that into the 5-volt section. And I use a white wire for grounding, and I'm going to put that into one of the 2 grounding ports that are present. So with my power wires in place on the actual Arduino board itself, I'm now going to plug them into the breadboard. I put the black wire on the positive rail, and I put the white wire, the grounding wire, on the negative rail of the breadboard. So let's add our first component to the board. We're going to add a simple switch. As you can see here, we need to make the switch bridge the middle gap of our breadboard. So I'm going to take the switch and I'm going to place 2 of the pins on one side of the gap and 2 of the pins on the other. Just like that, and you can see it's bridging the gap in the center right there. Remember that on a breadboard, power flows all along that rail on the side. So we're going to connect a smaller black wire to represent the power from that power rail to where the switch is plugged into the breadboard. And there we can see the connection. Now the switch has power going to it, but we have not completed the circuit yet. When the switch is pressed, power now is going to be flowing from one leg of the switch to the other. So we're going to put a data cable in for the Arduino board to be able to read that. So on the other leg of the switch, I took a blue wire and I put it into the breadboard, and now I'm going to put it in any one of these digital ports over here. It doesn't matter what port you choose, but just remember, because that is a port that we'll need to identify in our code later on. So now we're going to add a resistor in order to complete our circuit, and I recommend using a 220 for most Arduino projects. Go ahead and remove a resistor from its packaging, and what you're going to do is bend the legs down. And we're going to complete the circuit by finding the rail that power cable is on, and we are going to jump from that rail to the grounding rail, which runs along the side of the board. So here you can see in a close-up that the resistor is in the same lane as that data cable, and it's jumping over to the grounding rail where our white wire is taking the power back into the Arduino board and completing the circuit. This is a cap, and it adds a little bit of aesthetics to our switch, and it fits right over top, and you just pop it on, and now we have a functioning button. If we want some more responsive feedback that our button is being pressed, we can use an LED light. Any color works. There's 2 legs on an LED. The longer of the 2 is the anode, and that's where the power needs to flow into. So to get this wired into my board, first I'm going to fold it out and then fold half of it down. In order to wire our LED light in, we're going to need to reposition the resistor. So I removed it, and now I'm going to move the data cable back towards the power rail a little bit to give a little bit more space right there. And I'm going to take the resistor and I'm going to put it sideways so that the current flows to a different rail on the inner part of the breadboard, as seen here. Now it's time to use the LED light to bridge our circuit. We're going to take the anode leg, the longer one, and connect it nearest to the resistor, and we're going to bridge the gap and put the cathode, or shorter leg, in the power rail where the grounding wire, or the white wire, is. Now that we've completed the circuit, let's just take a quick overview of the wiring on the Arduino board. We have a black wire coming out of the 5-volt power section and a white wire coming out of the ground. And now we have our data wire, or blue wire, going into port 9. On the breadboard side of things, we have the 5-volt wire connecting on the positive rail. We have the grounding wire connecting on the negative rail. That's going to bring power all the way down. We have another black wire that's jumping the gap to where their switch is wired in. It's going into the switch. When it's depressed, power is going to go through. It's going to flow through that data wire to give data back to the Arduino, and it's going to jump back to the neutral rail using that resistor, which limits the amount of damage that can be done to the electronic components. All right, let's switch gears here and talk about how to wire in a potentiometer. I'm starting with just the power rails connected to my Arduino and to my breadboard to begin with. A potentiometer is an analog device which, when turned, gives a value from 0 to 1023, a 10-bit number. And it has 3 legs. We're going to place those at the edge of the rail on the breadboard like this. And we're going to see here that it's just put right up against the rail, which leaves us 3 paths that lead back towards the power rails. Wiring the potentiometer for power is a pretty simple affair. We're just going to take what we already learned with the switches, and on the back left corner is going to be where our power input is. So we're going to take a wire and we're going to jump from the power rail and connect it to the rail where the back left leg of that potentiometer is. And likewise, on the back right leg of the potentiometer, that's going to be our grounding pin, and we're going to put a jumper wire between that and our grounding rail on the breadboard, as seen here. So that leaves the middle pin of the potentiometer left, and that's going to be the pin that gives us the value. So I'm going to take a yellow jumper wire here. I'm going to put it in the middle pin, and then I'm going to select one of the analog ports on the Arduino. I'm going to choose A0, which is at the top of the analog ports. And now we have a fully wired potentiometer. It's going to get power from that black power wire, jump through the potentiometer, and come out through the grounding wire to complete a circuit, and it's going to be sending data through that yellow data cable. So that's it. We have wired up a simple switch with an LED indicator light. We've wired up a potentiometer. And here you can see my version of a simple controller in action. I have 2 buttons and a potentiometer for controls. I have them wired into my Arduino. The 2 switches are going into the digital ports. The potentiometer is going into the analog port. I have my 5-volt power port and my grounding port connected into the breadboard power rails. And everything should go according to plan. If you need to stop the video and look at the wiring here, I encourage you to do that. Also, at the beginning of the video, there is a schematic that you can pause and look at as well. So with the Arduino board powered up and my simple controller all ready to go, I can now see that my LEDs are lighting when I press the button. My board is connected to the computer, and everything should be according to plan. So let's run a Space Invaders game and see if it works. I'm turning the potentiometer, and you can see that the cannon is moving. I'm pressing one of the buttons, and it's firing. And now I have a working game prototype, which I encourage you to make use of to test your controller as well, using processing. So Enjoy the project, have fun with it, my electronical entrepreneurs, and keep creating.